Hi, algebra students. So we are continuing talking about slope. Today's notes are going to be on finding slope, with given 2 points. Finding slope when, I guess this should be when, not with. Finding slope when given 2 points. Here I go again, writing down wrong things. I told you all these videos would get less professional as we go on. Finding slope when given 2 points. All right, and so keep in mind and remember just, and you might want to always like just sort of make a little sketch of this whenever you're dealing with slope. Remember, we are still thinking about slope, dude, and we're thinking about positive slope, negative slope, zero slope, and undefined slope. But today we're going to look at what happens if you're given 2 points and you actually don't have a graph. So can you find the slope given 2 points if you don't have a graph? And so I just want to talk real quick. I'm going to grab a sheet of paper here. I'm just going to talk real quick about why this is important. So just a real quick personal story. So my dad works as an engineer, and a lot of times when they're building, they're engineering roads, they have to think about, okay, there's this mountainside, right? And so I'm going to draw in like this mountainside, and they want a road to maybe come around it or go up it even. Let's just think about a road going up it. But they know they're going to have to move some of this dirt to sort of level out the hillside so that a road could actually go up. Because there's a certain point where cars cannot get up a slope because it's just too steep. A car, with a regular engine in it might not be able to get up, so they would have to move some dirt. And so they might be thinking, well, okay, we need to like level this road out to make it sort of like looking like this and not as steep so a car could go up it. Well, of course, you cannot measure something like inside a mountain. And so a lot of times they'll make measurements and they'll say, well, okay, I know that the slope needs to be for every 1 foot increase, that it needs to, run maybe something like 20 feet as opposed to, something steeper like this. And so they'll know this measurement. And so they'll know that, okay, if this is, I don't know, we could say this is like my starting point 0, 0. So I know this needs to be at the point 20, over 20 and up 1. And of course we're dealing with feet here. But they would actually not like physically be able to see this, right? They would just know that, okay, if I'm starting here at 0 feet and 0 feet, and I'm starting here at 20 feet and 20 feet, then that's the slope that I need to start like chipping away. I need to start like removing all this dirt, right? They would need to take the excavator and start moving that dirt. And so a lot of times you're given like 2 locations, but you're not given like the actual slope that's found in between there. You have to actually, you're having to actually remove that dirt based on the 2 measurements. And so what we're going to look at, we're going to be given those 2 locations, and we're going to be asked to find the slope between them. So the instructions, we'll just jump right into an example. So the instructions might be to find the slope of a line which passes through the points 3, -2, and -3, -5. And of course, I still have these marks from where we graphed last week, or last notes page, and the ink came through, so you can ignore those. All right. So we're given these 2 locations, and we want to know what is the slope between them. Now, of course, one way I could do this is I could actually like come over here and I could start sketching out a little graph. And of course, you're probably already thinking to yourself, well, yeah, Miss Wallace, but you're probably going to teach us a quicker way to do this. Well, yes, I am. But I'm just saying you could do this. You could sketch out a little graph. And you could say, okay, here's my graph, and I've got the point 3, -2. So I would go over 3, down 2, put you a point, and then I would go, oh, that was not the right point. It was positive 3. Try that again. 1, 2, 3, down negative 2. 1, 2. I guess it would help if I plotted the points correctly. So there's over 3, down 2, and then negative 3, 5. Here we go. 1, 2, 3, and then we would go negative 5. 1, 2, 3, 4, 5. And so I would have this point down here, and I could draw my line, and then I could start counting my slope, and so I could say, okay, well, rise. This would be 1, 2, 3. The difference between them is 3, and then over 1, 2, 3, 4, 5, 6. And so I could say, okay, this is 3, this is 6, and so my slope would be 3 over 6, which simplifies to 1/2. And so that's one way of doing it. But of course, I would like to propose a quicker way of finding the slope between just given 2 points without having to go through drawing out a big graph and then counting. And so there's actually a formula for finding this. So this is what we would call the slope formula. And the slope formula goes something like this. It's that the slope, m, of course, remember m means slope, is equal to the difference. Now remember, on the top, and we think about this all the time, we think about, when we're thinking about slope, we think about rise over run. And remember, rising is really the y, it's the change in y over the change in x. So we're thinking about the change in y over the change in x. And so the way we can find it is if we are given these 2 points, we can take the second y coordinate, which up here, what I mean by the y2 in this little subscript 2, we would read this as y2. This is the second y value. So if you actually go up here and label these points, this would be what we call our first x value, x1, x sub 1, and then this would be our first y value, right? Because coordinates are always x and y. Over here, because this is our second point, we would say this is x2, and this is our y2. So we're given a pair of x's and y's and a pair of x's and y's. So y2, which would be negative 5 in this case, minus y1. Now think about what that gives us. That gives us the difference between the y's, right? So that's finding this distance, and then over the difference between the x's. So we want to find this difference, and so it is x2 minus x1. And so this right here is what we would call the slope formula. Now I'm going to give that to you, and then we're going to actually calculate it using these numbers, and I'm going to show you how it comes out to be the same as this, okay? So for this particular example, we would say, okay, our slope is our y2, which again, we would think x, y, x, y. y2 is negative 5, so we would write down negative 5, minus our y1, which in this case is negative 2. I'm going to put it in parentheses because that's a lot of minuses and negatives altogether, over x2, which in this case is negative 3. It's our second x value, minus, and then our x1, which was 3, so minus 3. And so what we're going to do is we're going to work out this math, and we're going to see what it gives us, because it should come out to be 1/2. So if you think about negative 5, take away negative 2, of course, minus a negative becomes plus a positive, so this is negative 5 plus 2. If you need to, type that in Desmos, that's negative 3. And then negative 3, take away 3 more, is negative 6. Well, a negative divided by a negative is a positive, and if I wanted to simplify 3 over 6, I could divide them both by 3, and 3 over 6 is the same thing as, guess what? 1/2. And so my slope here is 1/2. I didn't even need this picture to do that. I used my formula. I found the difference between the y's. So the difference between negative 5 and negative 2 is 3, which is what negative 3 in this case, that we got down 3. And then the difference between the x's, which was 6, in our case we got negative 6, but which 2 negatives make that positive of 1/2. So the slope formula works every single time to tell us the differences between our x's and our y's. So let's do a couple more examples of this. So next example, let's try, we want to find the slope between negative 3, 5 and negative 2, 1. All right. Now, when you're given 2 points like this, the first thing you want to do is write them down and label them. So this is my x1, y1. Just get used to doing that. x1, this is my first x value, first y value. This is my second x value. This is my second y value. And then you're ready to, get that slope formula memorized in your brain. You're ready to write down the formula and plug in your numbers. So it's y2. Notice the second one comes first. So y2 minus y1 over x2 minus x1. And so we're just going to plug in our numbers. Once we have this formula under our belt, and once we know which ones, making sure to keep them straight, y2, in this case, is 1 minus y1 is 5. Now, it's real easy. I've seen people make the mistake of doing like 1 minus negative 2. Like, you want to make sure, again, that you've got these labeled so you can see them very clearly. And then x2, which is negative 2, minus our x1, which is negative 3. And so we would do the math. So the slope between these two lines is 1 minus 5 is negative 4. And negative 2 minus negative 3 becomes plus. Again, you could type this in Desmos if you wanted to. Negative 2 plus 3 is 1. And of course, that simplifies to negative 4, because anytime we have something over 1, we can just write it as a whole number. And so we end up with negative 4 as our slope. All right, so you can do this with any two pairs. So I'm going to give you a pair of numbers now. Actually, before I give you a pair of numbers to try out, go ahead and try this one. You might want to pause the video. Let's find the slope between, let's do these two, negative 4, negative 3, and negative 4, 0. All right, so go ahead, label those. Use this formula, plug it in, see what you get. Pause the video. We'll go over the answer in just a second. All right, now I hope you paused the video and did this, because you might be looking around like, wait, what is the answer in the end? Did you get the answer of 0? You are wrong if you got the answer of 0. Let's see what happens here. So I'm going to label. So y2. All right, so my slope formula is m is equal to y2 minus y1 over x2 minus x1 is equal to, and so my y2 is 0 minus y1 negative 3, x2 negative 4 minus negative 4. All right, and then so on the top we get 0 minus negative 3. Well, minus and negative changes to plus. Same thing's going to happen on the bottom. 0 plus 3 is 3. And on the bottom, we get negative 4 plus 4, which is 0. And I bet a lot of you, maybe, hopefully none of you, but a lot of you maybe put that's equal to 0. 3 divided by 0 is 0, right? Well, if you happen to go to Desmos and you actually type that into your calculator, so let's try it. What is 3 divided by 0? Oh. It's undefined. It's not 0. You can't divide something by 0. What does it mean to divide something by 0? Cut it into no pieces? Now, you can divide something into one piece, which is itself, right? But if you cannot, it is impossible to divide by 0. So actually, when you end up with 0 on the bottom of your answer, like we did here, the answer is an undefined slope. Undefined slope. And think about that, what this would look like on a graph. If I plotted a point, I could just draw you a little tiny graph right here. If I plotted a point at like over negative 4 down 3, somewhere right in here, and then I plotted a point at negative 4, 0, and I connect those, what kind of line does it make? It makes a straight up and down line, which has a slope of undefined. So last example, and I'm going to squeeze it in down here at the very, very bottom. I bet you can go ahead and guess what kind of slope this is going to be. If we wanted to find the slope between, let's say, 0, 1, and 5, 1. Again, we would use our slope formula here. So I'm squeezing in on this last line, y2 minus y1 over x2 minus x1. Do you have to write that every single time? I would, because you need to memorize this. This is a formula that you're not given on the SOL, so you have to know the slope formula. Y2, y over x, it's backwards from what you think, and then the numbers are also backwards from what you think, 2 and 1. Y over x, and then 2, and then 1. And so if I label these, so there's my x1, my y1, x2, y2, y2 here is 1, y1 is 1, x2 is 5, x1 is 0. And so when I do this, 1 minus 1 gives me 0 on top. 5 minus 0 is 5. Now, if 0 ends up on the top, of course, yes, 0 divided by, and I can go to Desmos. If I'm going to do 0 divided by 5, that is 0. So that makes sense as far as 0 slope comes out. So if you have 0 on the top, your slope is going to be 0. If 0 comes out on the bottom, it's going to be undefined. Other than that, you're dealing with fractions and math like normal. So using the slope formula, here's what you need to know. Keep that out in front of you as you're doing your practice. Using that slope formula, finding the slope when you're given 2 points. Make sure you label them so you know you're plugging in your numbers correctly. And make sure you send me an email if you have any questions. Good luck practicing.